For lesson 4, this is actually lesson 4, part 1. We're going to focus on adding and subtracting rational expressions. And so just like when we had to practice how to work with fractions, just kind of basic fractions from our arithmetic classes in our elementary grades, we're going to have to review a little bit about how to add and subtract fractions. So basically, here are the processes, here are the steps that we do. We keep the numerator added together and we hold the same denominator. If they have the same denominator, we just add those numerators together, and then if we need to, we can simplify that fraction. We know how to simplify based on our previous practice. We should be solid on that. Over here again, we're going to do the operation on the top because they share that numerator, and then that will give us our answer that we then simplify to get our final simplified difference or our simplified sum. The key here is just like when you learn to add or subtract like terms, here we have 3/16 and 5/16, and together that makes 8/16. Just like if we had 3 x's and 5 x's, that makes 8 x's. It's the same idea of working with like terms. And so in order to add these fractions in arithmetic class, in our elementary grades, we would need to make sure that we had a common denominator so that they were like terms and so that we could add those expressions. Now, here on the algebra side of things, thinking back to chapter 12 of Algebra 1, that rational expressions unit, this is what we're doing today. Here in Algebra 2, just kind of revisiting this, laying the groundwork so we can do some more complicated things with it. We want to make sure that when we're adding these expressions that they have the same denominator. If they don't have the same denominator, then we need to work around that. So first, let's just make sure that we understand this process. These are the same, excuse the bell, these are the same things, right? This is x plus 2 times 4x plus 5. It doesn't matter the order because multiplication is commutative. But what we end up with here when I combine those is I get 8x and 10, sorry for the marker there, is going to give us 8x plus 10 over 4x plus 5 and x plus 2. We don't need to multiply that out yet. What I want to make sure that we do is we factor our numerator. I'm going to switch markers if that's okay. This is 2 times 4x plus 5, and this is 4x plus 5 times x plus 2. And the reason why I wanted to factor that is so that we can see how we simplify this rational expression. This is going to give us 2 over x plus 2, and that would be the final form of this rational expression. Over here, the same deal happens. We'll subtract on the numerator, and we've got the common denominator, so that works out fine. But that numerator, as we know from Algebra 1 and from the last several units, that can be factored. That numerator can be factored. That's a difference of squares. And so when we simplify that, we are left with the final form. Now we also have some limitations here. Like we need to make sure that we state that x can't equal -5, x can't equal -2, I'm sorry, not -5, -5/4, x can't equal -2, x can't equal +3. Those are some limitations to our expressions, and we'll chat a little bit more about that in class. But it might be useful for us to at least make mention of this original thing that x cannot equal -5/4 and -2. Over here, x cannot equal -3. All right, so again, the process here of doing that simplifying, doing that adding or subtracting, that simplifying is, is sort of requisite. I want you to try the letter C, but what I have here is I have it say, not just you try to do the whole thing, but you try to finish it. So when I say finish it, what I mean is we are going to go ahead and do the subtraction. And I wanted to make sure that I modeled this because if we're subtracting this numerator, I said I was going to switch from the blue marker and then I didn't. We've got 6x squared, but then we're subtracting 13x minus 5. If I'm subtracting a -5, that means I'm going to have a +5 here. That's really important for us to reference. And then in my denominator, I've got this 2x plus 5. In order to finish this, I want for you to factor this numerator and see if this fraction can simplify more. So go ahead and tend to that. Make sure that when you're done, you make the statement that x cannot equal -5/2 in this expression. Now, when we're talking about fractions without a common denominator, we need to remember or relearn how to make common denominators. And the way that we do that is we multiply by a factor of 1, but represent it as a fraction that maybe doesn't look like 1, to make sure that we can make a common denominator. So the least common multiple between 15 and 3 is 15. So if I want to multiply that denominator of that second fraction by 5, it would make 15 in my denominator. But I can't just multiply the denominator, I have to multiply the numerator because this number, 5 over 5, is 1. So I'm going to multiply this 1/3 by 1. That way it changes the way it looks without changing its value. Whoops. It's like going to the Valentine's dance and you dress up nicely. It doesn't change your identity because you're dressed differently. It just changes the way you look. So here we're just going to change the way it looks, but it still has the same value. All right? It still has the same value. This is equal to what it originally was. It's just represented as a non-simplified fraction, but it's a fraction with a common denominator, and I can add those numerators over that denominator to get 7/15. That fraction can't be simplified, so we're done. Over here, the least common multiple of 15 and 6 is 30. And so what we want to do is take this first fraction and multiply by 1, and this second fraction, and I want to multiply that by 1, represented in these ways, so that I am being very calculated on how I get 30 in my denominator. If we think about it before we do it, it makes it easy to actually do that work. So we end up with 14 thirtieths minus 5 thirtieths, and that will give us 9 over 30. Sometimes that fraction needs to be simplified, and this can simplify. It's 3 times 3 over 3 times 10. This is going to give us 3/10. So again, elementary arithmetic. Why is an Algebra 2 teacher taking this much time to talk about how to do elementary school? It's because we've relied pretty heavily on our calculators the last few years, and maybe that process of how to has kind of gone by the wayside. All right, and obviously through no fault of your own, right? You are doing the work of middle school math, you're doing the work of high school math, and you're kind of above doing this by hand. But where that becomes a problem is when you're going to need to do it with algebraic expressions, and you need to make common denominators so that you can perform those operations. So understanding the semantics, the science behind it, is going to be required. Write that down. And once you have all of those steps written down, then we can start to do that work. So over here, we can see that this denominator can be written as 3 times x minus 2. And this denominator is already 3. So all that we need over here to make it match that is we need to multiply. I know I said I wasn't going to use the blue marker, but I'm just going to write this x minus 2 over x minus 2. We're going to multiply by x minus 2 over x minus 2. That expression is equal to 1. When I multiply that, it now gives me x minus 1 over 3 times x minus 2 minus 4 times x minus 2 over 3 times x minus 2. These are the same thing, right? So I want to do this subtraction, but I might have to do a little bit of that distribution. If you distribute first to make sure that you do that well, then that is fine by me, all right? I'm going to subtract this well. If I take x minus 1 and I subtract 4x minus 8, I get negative 3x. Negative 1 minus negative 8 is going to be a positive 7. And that's going to be over 3 times x minus 2. There's not a common factor there. This is going to be our final answer. Of course, we want to make note that x cannot equal positive 2. It's helpful to make that note that our denominator can't equal 0. Right, over here, I want to make a common denominator here. I've got x, I've got 2 times x plus 2, I've got x times x plus 2. So it looks like this one needs an x. This one needs a 2 and an x plus 2, and this one needs just a 2, all right? So once we have that factored, it makes it pretty easy to identify what is needed in order to perform these operations. That factoring, folks, is so critical to your success. That's why being able to do that Algebra 1 factoring, to know that, hey, I need a 2, and I need an x plus 2, to make my denominator to be 2 times x plus 2. Here I need an x, here I need a 2, all right? Now when we've written all of our fractions of 1, then we can do our multiplying, we make our common denominator, and then we can do our combining, all right? So sometimes folks want to do this multiplication when they do this multiplication. So like go right from here all the way to there to say that I've got 4x minus 8. You are welcome to do that. Here, if I multiply this times 2 times 1, I'm going to get 2x plus 4. In my denominator, I'm going to leave that factored. This is 2x times x plus 2. Plus, I've got x squared, and I've got 2x times x plus 2, minus 4 times 2x times x plus 2. I have the same denominators, Now let's write our numerators added and subtracted together. If this is a strategy they showed you in Algebra 1, you can write this as plus the opposite if you want to. Add the negative there if you'd like, if you don't like to do the subtraction. And so this gives us x squared plus 2x plus 4 minus 4, that'll sum to 0. And then in my denominator, I've got 2 times x plus 2. Hopefully you notice that this form is not finalized because our numerator can factor. All right, and if it can factor, then we can start to see what our finished form will look like. We have one of these and one of those. We've got 1x and another 1x. Oh, it looks like I've got, for my final answer, 1 over 2 is my final answer. We did all that work and we got 1/2. All right, but you want to make notes here that as long as x doesn't equal 0, all right, as long as x does not equal -2, then we should be good, okay? I would like for you to try to finish this one, all right? In order for us to try to finish this one, what I want for us to do is factor those denominators. We need to factor those denominators so that we can do that work and do it well. So in this denominator, and if you want to write just the denominator separate, that might be helpful. This one has a factor of 2 also, x squared and 7x and 10. You need to factor these two quadratics and then see what is missing to make sure that you can make a common denominator and then finish that, right? Make that as easy as or as difficult as you need to. All right, that should wrap up our lesson. Hopefully that was a nice shorter video than these last ones have been. But obviously doing that algebra work and that arithmetic thinking is going to present some challenges for us. So make sure that we know how to factor, make sure that we know how to operate with fractions.